Hello, everybody. Welcome back from lunch. Welcome to my session, Angular, the .NET Pitch. My name is Ed Charbonneau. This is my second visit to Bulgaria and my first time speaking here in Sofia. So today we're going to talk about ASP.NET and using Angular with ASP.NET. So this is Angular from a .NET developer's point of view. And today I'm going to show how to integrate Angular with the .NET stack. We'll do an overview of what all of the stack involves. I'll be talking about 3 different possible solutions for how we can create an ASP.NET core application and utilize Angular on the front end. So hopefully this will be a good session to give you an idea of what type of problems you'll face as a .NET developer, what solutions are out there, and what the possibilities are for using Angular with .NET. We'll cover like an all-in-one solutions. We'll have one single project that covers the front end and back end full stack, and we'll use a single template to start off our ASP.NET application, and it'll integrate Angular for us and give us a lot of benefits out of the box. And then next, we'll talk about a 2-solution project where we use a separate front and back end and tie those things together using Visual Studio and ASP.NET. And then finally, we'll wrap things up with an example that shows how you can actually build mobile applications using Angular and share code between your ASP.NET web application. So it should be a pretty interesting solution. And it allows you to have some portability in your code and bring your application to more users. So let's start off with defining exactly what Angular I'm talking about. So when we say Angular these days, we're not talking about AngularJS. When we say AngularJS, we generally mean Angular 1X. So this is the 1X generation. When we go to Angular 2 and up, we drop this JS suffix from it. It's just Angular. And Angular donates to 2, 4, 5, and up. So they skipped 3 in there. I'm not bad at math. They skipped it, not me. So we're on Angular 5 now. So when we say Angular, we're talking about Angular 5 generally. And Angular has changed quite a bit from 1X to 2 and beyond. So in Angular 1X, we wrote a lot of HTML and decorated that HTML with attributes. And this allowed us to do things in .NET like write Razor syntax and do server-side processing of the HTML. In Angular, that's a different story. So we've moved to a component model in Angular, and that component model is wrapped in JavaScript, and everything is done in TypeScript. So with that in the picture, it changes the stack quite a bit for us .NET developers. Especially those using ASP.NET MVC. So when we're talking about Angular, there's a lot of things that come with it as far as tooling and parts of the stack. So Angular itself is written on TypeScript. So TypeScript is going to come along for the ride. We're definitely going to be using some TypeScript. And then to do compilation of the TypeScript and package our JavaScript files and static resources, we're going to use something called Webpack. So Webpack can be compared to a replacement for something like Gulp.js and bundling and minification tooling. So we'll have to have some Webpack involved in this as well. And then if we plan on doing any server-side rendering, which we'll see a detailed explanation of in a little bit, we're going to actually have to utilize Node.js. And all of these things are installed using NPM. So when you see me talking about all of these Angular technologies, you kind of get the idea of where does Microsoft fit in all this JavaScript world stuff. So that's what I want to show you, is where these things fit and how they kind of overlap and what comes out of this combination of tooling. So there is a lot of stack overlap between ASP.NET MVC and Angular, the framework. One of those things is Angular is very component-driven. So the components are written in JavaScript and HTML. And with ASP.NET, we're used to writing those things in Razor. So there's some overlap here. This is going to be the biggest point of overlap in the two frameworks. They're both responsible for templating and data binding. Again, we use Razor for that in .NET. We'll use some different methodologies of doing templating and data binding in Angular. But the thing we need to focus on right now is the fact that both of these frameworks have that responsibility. So we're going to have to choose one over the other. And then Angular also comes with routing. So the first things are very front-end development type of things, HTML components and templating, data binding. Those are all very much part of the view. Routing, on the other hand, doesn't quite fit into that same category, but Angular does that as well. So it's a single-page application type of framework. So we're talking about a SPA application, and Angular is going to need to handle routing. And we're used to setting up that routing in ASP.NET, and we're going to have some overlap there and have to make some decisions. Now, the main differences between those two stacks is, Angular is very JavaScript-centric, or TypeScript in this case, and it's very client-side. Now, it does have a server-side component to it that is the server-side rendering of Angular, and that's where the requirement for Node.js comes in. Since it's all written in JavaScript, it has to run in a JavaScript environment, so we can't exactly do that processing with .NET itself. So we're going to have some additional tooling if we'd like to do server-side rendering. And then ASP.NET Core, the views in ASP.NET Core are all handled on the server side. All the processing's done there and then sent down the wire. So those are the major differences. So there's a lot of things that overlap, but there's some unique properties to each of these. In your basic ASP.NET application, we have our MVC pattern, or model view controller. Our views mainly composed of CS HTML or Razor, and that generates our HTML and often contains some CSS and JavaScript. A lot of times we're using jQuery in this environment. And then we usually have our controller, which contains our business logic and handles some routing. And then our data access, we're talking to SQL. We might have something going through Azure. And we have our entity framework models that we work with. The data access part of this .NET ecosystem is very strong. And that's where one of the key pieces of ASP.NET is very important, is on the data access side of things. It does a lot of work for us. Azure's great service, and a lot of people like working with the easy models and entity framework to do queries. And it's very powerful stuff. If we look at MVC versus Angular, you can see that overlap. I've kind of marked out with a red X here at the top. Since Angular is very client-centric and it's going to handle all of the front end, we're not going to bother with CS/HTML stuff. So no real Razor going on in this application. It's all going to be taken over by Angular instead. It just doesn't fit this equation at all. And then also our routing is going to get transferred over to Angular. So that business logic, we're not going to have a lot of routing in there. Most of that's going to be handled on the client side as well. So it's going to be a single page application with Angular handling all of that. Now, what's really strong in this mixed scenario is the web API is going to tie this all together for us. So we're going to do a lot of calls to the .NET Web API and get JSON back and render those views with Angular. So again, we have all of these JavaScript-centric technologies, and we're talking about ASP.NET, and a lot of ASP.NET developers use Visual Studio. So how do all of these things fit into the tools that we're used to using? So I'm going to talk a little bit about that as well. And I'll do that through the course of the session with demos. So the first demo I want to show is what I like to call the all-in-one scenario. So this is going to be one solution. It's going to be an ASP.NET Core project that has Angular already integrated into the template with all of the bells and whistles added. Everything's already thought of for us. So if you're new to Angular, there's a lot of setup process involved in getting an application up and running. And if you don't know how to wire these things up, it can be pretty difficult, and this template handles all of that for us. And one thing about all of these technologies is they give us a lot of choices. So, we're deciding to make the choice of using Angular. We know that, but there's still a lot of choices to be made. One of those is we can build from the command line using a Mac, a Linux box, or a Windows PC, and we can also use Visual Studio. And you'll see me use Visual Studio throughout the talk, but it's important to note that the .NET CLI is there, and we could use this on a Mac without Visual Studio if we wanted to. So in the latest version of ASP.NET Core, ASP.NET Core 2, they've added a new Angular template to the File New Project experience. So when we do File New Project, you'll see that there's an Angular, there's even some React templates in there as well, and they all work in a very similar way. And when we run this Angular template application, it gives us like a hello world type of app. So you'll see this throughout all the demos today. And the application's very simple. It has a home, it has a counter that kind of increments a button, and it has a web API that's being fetched and displayed on the screen. And this is all stuff that you get out of the box. So let's go ahead and take a look in Visual Studio and see where that stuff is at. So first thing I would do is go File, New Project. And when the File, New Project dialog comes up, we have an ASP.NET Core web application. If you have ASP.NET Core 2 installed, this is where you'll see this new dialog come up. And you see we have an Angular application in here. And again, there's also React templates as well. So these all have something running behind the scenes called JavaScript Services. And I'll get into that in a little bit here. It's all part of this all-in-one solution. So we have our Angular template. I would hit OK, but this session is only an hour long, and it takes quite a while to install all of the dependencies that go along with this. So I'm just going to pretend I've done this and open a project that's already loaded and has that File New Project experience, just as it would be after it completed loading all of its dependencies. So go ahead and open this guy up. We'll do a little exploring here and see what's inside this template. So there may be some things that you recognize from an ASP.NET Core application or ASP.NET MVC application. And one of those things is we have a controllers folder, and this will have our controller logic in it. And then we have our views folder. We're not going to spend a lot of time in there, but it's important to know it's there. And then we have a new folder in here called Client App. This is going to be the front-end part of the application where we work on our components and our Angular part of the app. And this is all supplied to us out of the box. The first thing I want to look at is our home folder and open up the index page. And when I open up the index page, you notice there's not a lot going on in here. Okay? It's not the normal look for an ASP.NET MVC index page. What we have is a tag helper in here called app. Now, what .NET is doing with this view is it's just spinning up a bootstrapping piece of HTML. And Angular is going to look for this app tag. And when Angular finds it, that's where the application will be loaded for the client. And that's all of the Razor that you'll see in this application is just what's here. You're not going to write a bunch of Razor views and do model binding on your controller. It's all going to be done in Angular. And this is pretty much it. This is the last time you'll see Razor for this type of application anyway. So I'm going to close that out. And then next, you notice we have a controllers folder. And we have a sample data controller. So this has an API, web API in it. This is where all of our work is going to be done. This is that back-end part of the application I was talking about. This is where .NET is really strong, is in the web API portion and being able to talk to Azure and Entity Framework and SQL. This is where all of our strong suits are. Not a lot going on in the sample application other than just a simple controller here that's generating random weather data. So next, let's give this a run. Let's see what they gave us out of the box. On the surface, it might not look like too much. We're going to keep digging and finding out more about this project, and there's a lot that Microsoft has done to get us up and running without having to know a whole lot about Angular. Now, that's good and bad at the same time. There's a lot going on that we don't know about. There's also a lot that's been provided for us that if we learn about it, we can use it to our advantage. So here's our Hello World application. And it's got a very simple counter. So it starts at 0. If we click increment, it just goes up. It's very easy to understand. And then that web API I was talking about, we're fetching from Angular and putting into a view and displaying. And again, Angular's handling all the routing. So every time you see the URL change up here, Angular's handling all of that. So all the routing is in Angular. We have a loose plug, so pardon my dust. Okay, there we go. So let's look at the code that's behind this Hello World application. So to find the code for this, it's going to be under our client app folder. Again, this is our view for our application. And we have under there, we have our app and the components that belong to the application. And you can see in each folder, we have a clear component folder of those things that we saw in the application. So for example, we have the counter component. If I open the TypeScript for that counter component, you see this is just Angular here. And Angular is defining that this is a component. It gives us our template URL. And that points to our counter component HTML, which is going to be our template for this component. And then there's some basic logic behind here. We're going to set up a variable called current count, and then just increment this counter when the button is pressed. And this is all bound through Angular using their binding syntax. And this is the markup for that component. So you can see here that we have our current count being displayed and bound to this part of the HTML, and then we're binding our click event. And that's where the counter component gets the increment counter button click event handled, and then increments that. So that's a simple thing that's happening on the surface. So we can go in here and click increment, and we're just incrementing this button. There's a lot going on underneath the covers here, though. So remember, this is all running in JavaScript, and Webpack is behind the scenes, and it's doing something called hot module reloading. So what this is a mechanism for developers to iterate on the code very quickly. And to show an example of this, I'm going to leave this page open, and remember, we're on, say, count 5 here. And I'm going to go into the code base and change the code from this increment variable to decrement. Now, when I save this and go back to the browser, you'll notice the browser never refreshes. However, the counter just went back to 0. That's because we have that initial value, default value of 0. So it's read that again, but the code's been recompiled, and when I click increment, we're now going into negative values. So it's made that code change and uploaded just the bits that it needed to append that page and make that code change happen. All that's being done through Webpack, and it's been done behind the scenes from this .NET template. And I'll show you guys how that happens and what the internals of it look like in just a few minutes. We don't have a better extension cord. This one's keeps falling out. Sorry for the technical issues here, folks. This socket has seen its days. I'm going to blame JavaScript right now, because that's what I do anyway. That's all JavaScript's fault, somehow. So let's take a look at what's happening in the stack here. So if we're running in production, this is kind of the workflow that we have. Angular is running on the server side using Node.js to do server-side rendering. This is a stop or help alleviate some of the work from the client. So just like in .NET with Razor, we're doing some server-side rendering, but this time we're using JavaScript, and we're required to use something node-based to do that. So Microsoft has unique technology that's running to actually spin up this Node.js server and do this work for us. And that's called JavaScript Services. And then ASP.NET Core takes and processes that information and hands it off to the client side of the application. So we kind of have this workflow going on. If we're in development mode, Webpack is involved and is doing something called hot module replacement, and I kind of showed you how that works. And when we make a code change, Webpack is watching for those changes, and when it senses a change, it's going to recompile the application and replace the bits that it needs to get us up to date with those changes. So we don't have to keep stopping our application, recompiling, refreshing browsers. We can just keep working. Now, JavaScript Services is also handling this part. If you don't have this template, then you don't get this stuff out of the box. You have to set it up manually. Some of this does come with the Angular CLI, however. So let's go look at our fetch data part of the application. It's going to be very similar. This time we're calling out to our web API. And you can see the URL we're hitting is right here. So we're calling that web API controller and hitting that endpoint and getting back this weather data. Again, that's randomly generated stuff. It kind of doesn't even make sense when you look at it, but the point is to get data out of that web API and display it in this HTML page. And to display that data, it's bound to this view. We iterate over it using Angular syntax here. We can do an mgif and see if there's anything in that collection. If there is, we can iterate over it and display those items in like a HTML table format. So that's where this fetch data page is coming from. So this is using a combination of web API and Angular. And if we make code changes to it, Webpack is involved, and server-side rendering is involved through Node.js. So there's a lot going on behind the scenes again. Like I said, this Node.js stuff is being spun up, and Webpack is being called upon, and it's kind of being handled for us without us having to set it up or interact with it. So how does this stuff work? So rather than show you this cool template and have you run off and use it and then have to find out how all this stuff works after the fact, I'm going to try to look into the black box for you. And I have another demo that I'd like to show. And this is an isolated demo that's just showing off the node services part of the template. So there's no MVC, there's nothing, but we're utilizing that node services or JavaScript services component. It's a piece of middleware for ASP.NET Core. And what it allows us to do is talk to Node.js from C#. So this is really cool stuff. So in order to set this up, I need to register it with Dependency Injection. That's how the module is made. And we'll use this node services service, and we'll new this up with our dependency injection. We'll go grab it out of the dependency injection container, and once we have it, we can call this method called Invoke Async. What Invoke Async gives us is the ability to call upon any node module that we have in our application. And we can pass values to it, and we can get values back from it. So when I call Invoke Async, I expect a string back. And I'm going to call greeter.js. I don't need to tack the JS on there. And then I'm passing in a variable DevReach. When I get the response back from that, I'm just going to write it straight out to an HTML stream. So if I run this, I should get a browser that pops up, and gives us the result from that greeter.js file with the parameter of DevReach. And this may be a little hard to see in the back, but I have a hello from DevReach displayed up here in the browser. So what it's gone and done is, in the code for this, if we look at greeter.js, it's a very simple module that all it does is concatenates hello world onto whatever variable I pass it. So this is a very, very simple explanation of what's going on, but we can do a lot more complex things with it. We could call Node APIs that have image processing capabilities and resize images. We can call Webpack and have it do things. We can call Node and spin up an Express server and give it things to render server-side, which is what they're doing in the template. So this gives you a look at what's going on inside that template, the things that they've created to try to bridge any gaps between ASP.NET, MVC, and Angular and allow us to work with them without having to do a lot of research on the technology behind Angular to get us up and running quickly so we have time to get over that learning curve and learn about these things at our own pace. So the upside of this is we have one solution. It's hosted on one server. The things like Webpack and Node.js are abstracted for us. We don't need to know about those. It's a nice have to know about those. So if we need to do any additional configuration, which eventually you will need to do, at least we can get up and running without having to know those things and learn them as we go. It's Visual Studio friendly. You can do it right out of File New Project, and we don't have to visit the command line if that's not a place we want to be. A lot of people like the Angular CLI. So if you're a big fan of the Angular CLI, this probably isn't the right choice. And we have a very tightly coupled server and client here. If you need to separate those two things, this isn't the better choice. And then there's that factor of the black box. There's a lot being done for us. And if we don't dig deep to figure out what those things are, then come catch us later on if we're not quite aware of what's happening under there. And one of the things that I was working on with our team at Progress is a way to start up the same File New Project experience, but with Kendo UI. So what we're looking at releasing sometime next year is a way to do File New Project or .NET New, and say, give us a Kendo Angular application to start with. We'll get all that Node services stuff running on the back end that Microsoft created, the exact same Hello World template, but we'll have really cool stuff in there like charting, drop-down controls, and all that rich UI stuff that you'd expect from Kendo UI. So this is something we're looking at extending what Microsoft has done and adding some more value to it. So scenario 2. This is going to be where we have a separate web client application, and we're just going to tie into Web API. So in this scenario, we have two solutions in one project. They don't necessarily have to be in one project either. Just for today's demo, I'm going to do it in one project. We're going to have one ASP.NET Core Web API project and one Angular solution. And we're going to tie those things together. And for this, we're going to use the Angular CLI for the front end and Web API for the back end. So a little idea of what that scenario looks like. We're going to have these two separated pieces with their own responsibilities. And Web API is going to supply the back end. And we're going to pass JSON data over to Angular, and Angular is going to consume that and do all of the things that Angular needs to do. So again, Angular is taking over the entire role of the view. And in this case, we're not even going to bother with MVC. We're just going to be writing Web API stuff. To set this up, I'm going to do File New Project Web API. And then I can go into my command line, and I can spin up my Angular CLI using the Angular CLI syntax and say ng new, and then spin up the front end of the application. And again, to save time, I'm not going to go through all of those steps, I'm going to open a project that's already been pre-configured. And it's just walk through this basic file new project steps. I haven't done anything really complex with it, except for adds a little bit of functionality to make it more like that hello world we saw earlier. And I'm going to open the wrong project just to throw you guys off. Just testing to see if you're awake. It's one of those things with computer programming. Naming is hard. Remembering those names is hard too. So here we go. We have this opened up. This is going to look completely different from that last project we have. I'll collapse these guys down, and you can see I have a back end, and I called it backend for Angular, and the front end is called client app. Now this is my web API where I did file new web API project, and then this is where I used the Angular CLI to generate the client application. Now, how did I get the client application into Visual Studio? Well, Angular uses all web technologies, so this is actually really easy in Visual Studio. What I can do is come up to my solution and just do add existing website, not existing project. It's going to look for a csproj file if we do that. We do add existing website. When we do that, it just loads nicely into Visual Studio, nothing crazy to configure. It works out of the box. It works so good out of the box that Visual Studio will even see that there's a package.json file in there and attempt to load any dependencies, do an npm install if that hasn't already been done. So we'll do that automatically. Anytime we're in Visual Studio, we open our package.json file and save a change, it's going to run an npm update for us. So Visual Studio works really well with these technologies. So let's spin this up really quick. And what we're going to see is this very bare bones. It's not like the other project. There's no hello world there. What is there, I have added. And by default, it decided to go to the web API and call it. I'm going to take this off of here. And actually, it may be running on a different port. It likes 4200. Let's try that one. Nope. Oh, let's try this again. Oh, my mistake. Yeah, so I'm actually proving my own point here. When I spin this up, it's going to the web API because it is a web API application. So we need to do some additional work here to get the client side of the application up and running. And to do that, we're going to have to utilize the command line. Now, we don't have to actually exit Visual Studio to do this. And I think I may have lost my mouse. And I may have locked up completely here. Nope. I have no cursor. This is fun. Ah. Did it? There we go. It came back. Yay! Ghosts in the machine today. Again, I'm going to blame JavaScript for that. I don't know how, but I'm sure it's its fault. So what I need to do is I need to run an Angular command here, an Angular CLI command. And Microsoft has a really cool tool for this. So it's called Npm Task Runner. And this is an extra tool that we need to install. Once we have that, we get this nice little handy window here. And any tasks that it sees in our package.json file, you can see here we have scripts, and we have Angular, start, build. What we want is this start command. So instead of going out to the CLI and running that, I can just come into the Task Runner Explorer and double-click on Start. You'll see the command line window actually pop up in this frame, and it kicks off that command for us. So now it says we can go to localhost 4200, and I can wipe this guy out and do 4200, and now I have my application. Again, very bare bones, hello world. Not like the other one. There's not as much done for us. And I've went back and created the fetch data portion of it. And I've left it kind of plain and simple to prove the point. You know, there's nothing being provided out of the box. Everything that's here I had to handwrite. So this is a good way to start from scratch. And if you know Angular well, but you have developers that work in .NET and they want to use Web API, this is a good way for those two teams to work at their own paces with their own technologies. So you saw that little problem I had at the beginning where I was going to port 5000 where our Web API sits, but the client side of the application sits on 4200. Now this is something that you're going to run into when you try to set this up. Angular is going to look on the domain that it's on for that Web API endpoint. So it's running on port 4200. It's going to look for the Web API on port 4200 as well. So we have a couple choices to make. We could try to hard code it. That would be bad. And it's also that's going to cause a problem where the domains are different, and it's going to set off cross-origin resource sharing, and the browser is going to deny the request. So what we can do, there's actually a mechanism built into Angular. And if I go into my project, you'll see a configuration file called Proxy Config. What Proxy Config does in Angular is it says, I have a request. It matches this pattern. I'm going to go forward that request to somewhere else. So in my Proxy Config, I've configured it to look for that API path. And when it finds the API path, it's going to change that part of the URL to look on localhost 5000 where my API actually is. So that part of the URL gets swapped out and called like it's supposed to, and there's no cross-origin problems, and the application's able to consume the data. Now this is something that's part of Angular. It's meant to be used this way. So this is definitely a hiccup you'll run into if you're trying to set up Angular and Web API to work together. So talked about Proxy Config. Let's talk about pros and cons of this solution. Again, we've decoupled the client and server. If you're building something larger scale, this is a better option than the first. If you have independent developer teams that enjoy using the Angular CLI, which there's no reason not to, you can use the Angular CLI with this. Angular CLI at the current state does not work with the previous solution. It's because of the folder structure in that template. It doesn't match what a normal Web API, or sorry, normal Angular application looks like. And there's nothing pre-configured for us, so there's no black box. Whatever's in this project, we put in this project, so we better know about it. On the flip side of it, there's some issues you saw with that proxy config. We're going to have a possible issue when we publish this. Does it need to be on 2 different servers? Is that what we want? There's just some added complexity there, and it forces us to do everything ourselves. You know, there's nothing provided for us. There's no guidance other than some documentation. Let's look at one more example. And this one's a pretty unique scenario. What we're going to look at is a scenario where we want a web application, but we also want a native mobile application to companion with our web application. And when they built Angular, they actually built it with the ability to target different rendering mechanisms. So what I'm saying is we can swap out the template engine in Angular and allow it to target things other than the DOM. And there's a really great tool out there by Progress, or framework, that's called NativeScript. And it can also use Angular to build native iOS and Android applications. So let's look at how we can build a web application using ASP.NET Web API in the back end, using that all-in-one template, and share some of the code that we're writing for Angular with a NativeScript app, and have web, iOS, and Android out of the same code base. So again, we're going to have two solutions. This time, one is going to be that all-in-one. And the second solution in our project is going to be the native script application. It's going to be a native iOS and Android application powered by Angular and native script. If we look at that stack, let's look at what native script is. We have Angular, TypeScript, NPM, Webpack. We use these with native script, and on the output, we get Angular and iOS applications. What native script is not is a hybrid application. There's no web view in here. So this is actually a native iOS or Android application. It's not Cordova, and it's not a progressive web app. This is something that you can put in the store, and you can install on your device. And you don't have any of the performance issues that you might have from a hybrid application with a web view. Now, to build this, again, we're going to do a couple file new projects. We're going to do the Angular file new project that gives us the all-in-one. We could also use the other scenario and have three solutions in the project. Just for demo purposes today, I'm going to use the all-in-one, but it would totally work with the other. And then to create the Angular part of the application, or the mobile part of the Angular application, I'm going to use NativeScript Sidekick. So this is a tool that you can download from the Progress website, and it gives us those file new project experiences that you would expect in Visual Studio. Now, next year, there are plans to have this type of tooling in Visual Studio. So you could actually go in, do file new project, native script with Angular, and get this same type of thing right inside of Visual Studio. And it will allow debugging and all of the press start to run type features you'd expect from Visual Studio. At current state, we have to use NativeScript Sidekick or the command line to kick off a new NativeScript application. So you saw the left-hand side of this a little bit before. This is from that all-in-one project. This time, we're going to access the web API from the mobile application as well. And we're also going to share code, TypeScript code, with NativeScript and the Angular application. So let's kick this off. Again, not going to go through all the motions here. We're just going to open up an existing application that I've done some work on. So this had a little bit of extra work to create a NativeScript application and match it up with our Hello World experience. So we'll get this guy up and running. You'll see two different projects in here. One will be the NativeScript project. And what's nice about NativeScript is just like Angular, it uses all web technologies. So there's things in, all the things in NativeScript are recognized very easily by Visual Studio. And since they're all web technologies, once again, to add a NativeScript project into Visual Studio, I can just do add existing website. Because it's JavaScript, CSS, and XML, Visual Studio understands that all of those are web things, and it loads them in just as a website. Now, I'm going to go ahead and kick off our web server and our client application. It's all in one, just like we saw before. And I'm kicking this one off using the non-IIS version of the hosting for ASP.NET Core. And I'm going to open this URL in my browser. And you'll notice it's an actual IP address instead of localhost. This is because I'm going to be using a mobile application with it. And in order for my emulator to be able to find the web endpoint, it has to have an actual real IP address. Your emulator or device you have hooked to your laptop isn't going to understand where localhost is and where to look. So I've assigned it an IP address, and I've opened that port on my firewall for it to be able to accept that URL endpoint. And again, this is the same exact thing that you saw before. But now we have a native script application in here as well. And the next thing I need to do is come into Visual Studio and go to Tools and open the Visual Studio emulator for Android. And I've already kicked off the emulator, so I've got my emulator up and running. And I have my native script application in my project. I need to run that now. Until the native script sidekick tools get released, I have to do this from the command line. But again, I have my Npm Task Runner. And native script is all based on JavaScript technologies, so I can use NPM with it. And in my Task Runner Explorer, I have a task called LiveSync. If we look at our package.json file, at our scripts, this LiveSync task runs tns run Android. What tns run Android is going to do, it's going to tell native script that we're going to run an application targeted for Android. It's going to build it for Android. And then it's going to use something called LiveSync to push it onto the device. And it's going to give us that same ability that Angular has with Webpack to do hot module reloading, but it's going to do it on a native mobile application instead. It's very similar. It's not exactly the same, but you get the same development experience where you don't have to manually go in and reinstall your application every time there's a change. So I'm going to double-click on LiveSync. You'll see it do tns run Android there in the window. And then I'm going to pull up my emulator, and it should automatically open to an Android application. And there's native script coming up with LiveSync. And I've recreated this application. This didn't come out of some of this came out of the box. The template for the tabs came out of the box, and I added my own code to the tabs. I have my counter, so I can increment my counter. Again, this is a native application. And I can also fetch data and display it in my native application. So this data is coming from a web API endpoint hosted on .NET, and it's using Angular code and being translated into native iOS, or native Android in this case, API calls on the device. So this is pretty cool in itself, but what's really amazing here is my application code for the Android application is using shared code from my web application. So in my app, I have this folder called shared libs, and that counter component is in here, and I've stripped away the template part and abstracted just the base of it. So what does the base of it do? It sets up a variable and increments a counter. Now, in my actual counter application or counter component, what I can do is inherit from that base and then just attach the template to it. So I'll have different views because a mobile device isn't a web screen. The views are written in XML in native script, and they're written in HTML for the web. So I need different templates, but I can still reuse the core logic here. So all I do is extend it or inherit from the base, and I get all the functionality from the base. And then if I look in my native script application, I also have a shared libs folder. Now, for demo purposes, I'm just using a simple copy script to get these files from one code base to another. That's probably not the best practice, but it gets the point that you can accomplish this. You can figure out the method of transporting those files and, or bundling them and distributing them however you'd like to do it. But the point here is I can reuse this code, and if I go into my tabs on my mobile device and I look at the counter component, you'll see it looks almost identical in here. I believe there's one additional definition inside the component rather than the other one. There we go, there's two. But the base is the main point here. I've extended this. Any code that's in the base component I'm inheriting from, I get. Now, I can also do this with my fetch weather component, which I have in here. And I've abstracted the fetching of the data into a service that I can share between the two applications. So if I open my weather service, you can see I have an Angular service. And the Angular service isn't going to change from the mobile device to the website. It's the same service. All it's responsible for is going out to the endpoint, collecting some data, and maybe massaging that data and sending it to a component. The component does the consumption of it. So it's not attached to a DOM. It's not attached to the XML. It's a completely reusable component I can use. So that's in my shared libraries as well. So if I go into fetch data, and I open up my component here, you'll see I just have some code to go out and get that service and run it. And this is about the same code that is in the web application with just some minor changes. The main point, though, is that these two fetch data components both call the same weather service. And I don't have to write it twice. I don't have to write it for mobile and write it for the desktop. I've written it once, and I just transport that code. Like I said, you can use some kind of bundling and packaging system. In my case, I'm just X-copying it. There's some better practices out there to do this, but just to make things quick and easy, all I have to do is run this task using NPM. It'll kick off an X-copy and populate the native application with the code base that's shared between the web and the client. So we have code sharing, and we have a similar experience with the web and on mobile. And we're able to share some of these things. The things that are going to be different are going to be the views. So I've got a good list here of what can be shared. We can share Angular services. We can share some of the core business logic. We can even share CSS and Sass between these two things, because the native script application can translate Sass into native iOS and Android values and modify the look and feel of the controls in those OSs. This is really good, especially for Sass coloring variables. So we can write those once. We can have a set of theme variables we can share across the two projects without having to recreate those in two different places. So if our brand of our product changes, we can change the variables in one place and access those from both applications and make that change in one place. What we can't share, anything that attaches to the DOM, we can't share. The templates themselves we can't share. They're very different. The markup that's used for the HTML part of Angular is quite a bit different from the XML markup that native script uses. So we're not able to share those type of things. Now, native script can use things like the curly braces, the Angular methods of iterating over templates and things like that, but the underlying HTML like inputs and tables and things like that are wildly different from the XML markup that you'll find in a native script application. So those things we can't share. So the pros and cons of this, I left really cool off of there, but I think it's really cool. So I think it's really cool stuff. We can reuse some code. When you're using native script, you're using Sass, CSS, JavaScript, TypeScript, Angular. It's stuff we already know if we're web developers. So we get to reuse those skills, and not only the skills, but some of the code as well. We don't have to learn new things. Learning is hard. The downside of this, we are increasing the complexity of it, but we're adding a lot more value to it as well. And then the last one here is cross-origin resource sharing and firewalls. Getting this scenario set up for this demo is actually kind of difficult. I have to open ports on my laptop firewall to allow the emulator to talk to the web API. It's just hurdles that you're going to run into as a developer trying to set these things up. And then cross-origin resource sharing is going to happen from creating those web API calls from the device, since the device isn't on the same domain. And the core setup in in C# is actually really fairly easy. So it's not a big hurdle. It's just something that you need to be aware of if this is something that you want to pursue. So if we go into our startup CS in our application, you'll see the cores module being used in here. Actually, maybe in program. Well, I don't see it in there. I may have found a way around it. But for the most part, that may be something that you need to look at, depending on how the website's hosted and how the device is handling those requests. You might need to set up some cross-origin resource sharing on your web API. So I'm going to put up some links for everyone. I'll tell you a little bit about me while you guys have a chance to take a picture, copy anything down that you would like. My name is Ed Charbonneau. I'm a developer advocate for Progress. You may have known us previously as Telerik. I work mainly on the ASP.NET UI for ASP.NET MVC, UI for ASP.NET Ajax, and UI for ASP.NET Core. I do a lot of writing for Telerik. You'll find me on Channel 9. You'll find this video, or a video of this session on Channel 9. It's being recorded here today as well, but if you want to share it with your friends immediately, you can find it on Channel 9, share it with them there. I've written several articles about this, so if you want it in a written format where you can go over it with your own eyes on your own time, there's a couple links here at the bottom that'll help you out with that. So make sure you grab those links if it's something you want to read about. Thank you guys for having me out. If you want to talk more, I'll be at the Progress booth. There's several of us up there to continue the conversation. Check out some of the demos that we have. We have some really cool UI tooling. Lots of great stuff coming for 2018. So stop by and say hello, get a t-shirt, and have a chat with us. Thank you very much.